let's use those formulas that we just got to go back to this problem here and try to simplify that. All right, so what we had for this is that the right rectangular method is going to give us 1 over 50 times the sum from I to 100 of 1 plus I over 50 squared. All right, so let's try to simplify this sum. The first thing I see here is that we can separate, well, no, we can't because we have the square here, right? So with that square, what are we going to have to do first? No, we can't use any of those formulas yet. Yeah, multiply that out or expand it would be another way of saying that. So we're going to expand that first. All right, so this is going to equal 1 over 50 times the sum from I equals 1 to 100. We're actually going to have 3 terms here. So 1 squared is 1. Then we're going to have 1 times I over 50, but we're going to have 2 of those. So we're going to have what? I over 25. And then I over 50 squared is going to be I squared over 2500. Okay, now I'm going to do 2 things in the same step here. I'm going to split this up into 3 separate sums. All right, so this whole thing right here, and I'm going to put this in a bracket. This whole sum right here can be split up into 3 sums. A sum for that one, a sum for that term, and a sum for that term. Now when I do that, I'm going to factor the constants out. So the constant, there is no constant in this one besides just the 1. I'm going to leave that there. The constant in this one is going to be 1 over 25. So I'm going to factor that out, and I'm going to factor out the 1 over 2500 in this one. All right, so I'm doing a couple of things here. If you have a question about what I did, let me know. So what I've done here, I took each one of these terms and I wrote it as its own sum. Okay, that's the bottom left formula on that formula sheet I gave you. Basically says that if we have a sum of a sum, then we can split it up as the sum of the sums. And it's confusing when they're the same word. So if we have the sum of some things added together, we can add together the sums of those individual things. And then the other thing that we're using is the constant multiple one that says we can factor out the constant. All right, so now we can evaluate each one of these sums using those formulas. So that first one, don't forget that 1 over 50 out front, that's important. The first one, the sum from I equals 1 to 100, that's the first one. That's the first formula. So if we add 1 together 100 times, it's going to be 1 times 100, which is 100. Okay? Then we're going to have 1 over 25 times. Okay, this time we're adding I together from 1 to 100. So the formula we're going to use is the n times n plus 1 divided by 2. And in this case, n is 100. So it's going to be 100 times 101 divided by 2. Plus 1 over 2500. Now we're going to use the I squared formula, which I don't know off the top of my head. N times n plus 1 times 2n plus 1. Okay. So n is 100 times n plus 1 times 2n plus 1 divided by 6. And we're multiplying that times the 1 over 2500. Now, this looks kind of complicated, but from where we started, from having to add 100 different things together, I think we're in pretty good shape, because you can just punch that into a calculator and it'll tell you what it is. So go ahead and do that. Is that rounded?
Yes.
Okay. So this is going to be approximately 8.747. Now, that is pretty different from what we got with 4 rectangles, isn't it? With 4 rectangles, we got 10.75. So we're off by 2 whole points, 2 whole numbers, which is almost 20% difference. Hopefully, this is a better approximation. It should be. But what do we know about this approximation? It's still an over approximation, right? This should be bigger than the actual value. So what I want you to do right now, if you haven't done it already, is type this into your calculator. Figure out what the value of that integral actually is to the nearest thousandth. We'll round it to the nearest thousandth since we rounded this to the nearest thousandth. 8.667 rounded to the nearest thousandth. Okay, so we're still a little bit off. We're right on with the ones place. The tenths place is off by 1. So we're actually off by less than 1/10 here. But it's still not that close, is it? So you can see that we used 100 rectangles here, and if we had tried to do this by hand, we would have done a lot of work to get an answer that's off by a little under 1/10. And when we're trying to get answers that are accurate to the nearest thousandth in general, that's still not very good. So what's the next step here? Increase the number of rectangles. How many?
10,000.
Okay. You could do, you could say 10,000 or a million or 10 billion or a Google, or you could just say that we're going to let the number of rectangles approach infinity or increase without bound. And so what we're going to do on Monday is we're going to look at how we can take something like this, and rather than just put 100 in here, we'll use that formula we got for n and see if we can use some of those sigma formulas to simplify that. In fact, if you've got some free time over the weekend, you can have some fun with it on your own if you want.